Hello everybody, welcome to my channel. Um, in in this in this video, I've got a special treat for you all. Today we're going to be writing a Hello World type of program on the PlayStation 3 for the Cell Broadband Engine architecture. Let me show you this really cool book I got. Okay. It's called Programming the Cell Processor by Matthew Scarpino. Yeah, this is the book that I've been studying to learn how to program the PlayStation 3. Switch over to my HDMI input here. As you can see, we're looking at Linux, Fedora Linux running on my PlayStation 3. There's my CPU info in case you're curious. Now, before we get started, I just want to make sure that we're all on the same page. So really quickly, I'm going to give you a brief introduction to the PlayStation 3's architecture, and the kind of the special properties of the Cell Broadband Engine, which is the CPU of the PlayStation 3. I've got a PDF here, which is pretty good. It's by this guy, Hiroyuki Machida. And if I scroll down a little bit, let's see, a little bit more. Okay, here's some information. Now, as you may already know, the PlayStation 3 is famous for having a very difficult architecture to program for. And here are some of the reasons why. First off, it is a heterogeneous multi-core processor. And what that means is, well, multi-core obviously means that it has more than one core in the processor, and heterogeneous means that the cores, there's more than one type of core, basically. Like if you think about like your modern like Intel x86s and like your Ryzen AMD CPUs, those architectures are called homogeneous, and that's because all of the cores on a all of the processing cores on like a Ryzen CPU are basically the same. They're interchangeable. You can treat one just like you treat the next one. You can run the same. They all run the same type of code, the same instruction sets, all that. So it's a little bit less complex than the heterogeneous design, which is what the PlayStation 3 uses. Basically, the PlayStation 3 has two different types of processor cores in its CPU. It has one core called a PPE, and it has 8 cores called SPEs, or SPUs. They can also be called PPU, SPUs. That's interchangeable. Now, that's a grand total of nine processing cores on the PlayStation 3 CPU, which is ridiculous if you think about it, because it was developed in 2005, I guess. The PS3 was released in 2006, so yeah. this architecture came out of the early 2000s, uh, at a time when multi-core processing was still a little bit more new, and it wasn't it wasn't so widely implemented as it is today. So yeah, imagine 2006, Sony comes out with the PlayStation 3, and they put nine freaking processing cores on their video game console CPU. It's ridiculous. Um, Now, some of the quirks of this type of setup is the fact that these two different types of cores, the PPUs and the SPUs, they do not have the same instruction set. They have different instruction sets. They're similar instruction sets. They're very RISC. Uh, uh, it's a RISC design, a reduced instruction set design. But at the end of the day, the SPEs have a different instruction set than the PPEs. Okay. What that means is to write code and to build applications that can run on all of these cores. It requires two separate tool chains. To write the different sets of instructions for the different cores. That's one of the things that makes developing on the PlayStation 3 a bit of a headache, right? Now, see, here's a picture of the chip. Yeah, so basically, your PPE core or your PPU core is it's binary compatible with the PowerPC 970 chip. Basically, it's a PowerPC. It's basically a G5, like they used to put in the Macintoshes, the Power Macs. There's a few differences. The cache on the G5 in the Apple computers is a little bit beefier than the cache in the PlayStation 3. But aside from that, yeah, it's basically a PowerPC 970 chip that most of your code runs on. This is kind of like your it's kind of like the executive core. It's the queen bee. If you consider the PPU core like the queen bee, then you can consider the SPU cores to be like worker bees, and they're very good at what they do. They're a little bit of a simpler design, which I'm not really going to get too much into. Basically, like, all you need to know is that the SPU cores are designed to accelerate certain types of workloads, basically, and they're designed to be able to process large amounts of data very efficiently, and they're very good at doing linear algebra, basically solving matrix manipulation problems, matrices. If you've ever taken linear algebra, then you're familiar with doing operations on matrices, and that makes them very good for stuff like image processing, or like scientific workloads, and the program that we're going to be writing today is going to take advantage of a single SPE core. Basically, the way this program works is it starts execution on the main PPU core, the the queen bee. Pretty much, basically all programs start on the PPE core, the PowerPC core, and what you have to do is on your code that's running on the PPE core, you have to load your SPE programs, which is obviously compiled separately. You have to load your SPE programs onto the SPE accelerator core in order for it to run, and that's basically the long and the short of the program that we're going to be writing today. It's going to be a simple, like hello world kind of thing that starts, it starts execution on the PPU, the general purpose core of the Cell Broadband Engine. It's going to load some SPU code, some very simple SPU code, onto one of the one of these SPE cores, and it's going to execute it, and we will see the results of that execution, and then the program will terminate. I have one. See, this is the same picture as the one that was from the PDF. I can actually blow it up a little bit. Yeah. So that's a pretty good picture of what the architecture of the Cell Broadband Engine is designed like. You've got 1, 2, 3, 4, 5, 6, 7, 8 SPE accelerator cores, and you've got your PPE main executive core. This is the core that runs the operating system, the PPE. Here, where my mouse is. This thing in the middle called EIB, that stands for Element Interconnect Bus, which I'm not gonna get into, but it's actually also pretty impressive in its own right. It's the bus that all of these elements use to kind of like sling data to and from each other at super duper high bandwidth, very high throughput, information throughput you can get from the element interconnect bus. It's very impressive. But that's beyond the scope of what we're doing today. So, all right, let's get this party started. Let's see. I can actually close this window or close this pane. Okay. I'm going to change to a directory that I have called cell. This is where I keep anything that I write that is meant to run on the Cell Broadband Engine. We're going to create a new directory. Call it basic. And okay, let me I have to refer to my textbook here. Get that open. Okay. Now, the first thing that we're going to do is we're going to write the SPU program. We're going to write the program that is going to execute on the on one of the SPU cores of the Cell Broadband Engine. And we're going to write this one first because it's extremely simple. All it does is, it sends out a message to the terminal just saying hello, basically. So, okay. I'm going to call this SPU basic. And okay, this is a extremely simple little program. It's just going to output hello to the terminal. And the language that I'm working in is just basic C. Nothing fancy. Here's our main function. All right. Now, you may have already noticed that that's a very strange looking main function. Normally in C programs, the main function is declared very differently than this one here. That's because it's a SPU program. It's not a it's not a normal program. So yeah, basically, this main function is going to be called and you can have three parameters that you can pass to it, and their type is unsigned long. So if I'm not mistaken, a long is 128 bits on the Cell Broadband Engine architecture. Can't remember if it's 64 or 128, but I'm almost positive it's 128 bits. Anyway, so yeah, this main function is going to get initialized, and we can pass it three 128-bit arguments, basically. Now, I'm just going to printf. I say hello. My thread ID is %LLD and we're going to be displaying the contents of the SPE ID. The SPE ID argument. And then we're just going to return 0. All right, that's it. That's this is our SPU program. We're going to assemble, well, we're going to compile this program with a very special compiler, the SPU toolchain, so that it can run on a SPU core of my Cell Broadband Engine processor. So let's save that. Now I'm going to do the PPU program. We'll call that PPU basic. Now, this is the main program. This is the program that we're going to execute. This is the program that we're going to execute, and this is the program that's going to load the other program, the SPU program that we just wrote. It's going to load that onto one of the SPU cores. And now the whole point of this exercise is to show the process of how to do that, basically. One of the most important things that you have to know, or one of the most basic things that you have to know if you're going to be programming the Cell Broadband Engine on the PlayStation 3, is you have to know how to load SPU programs onto your SPU cores. So that's what we're going to do right now. Alrighty, going to include oh, and by the way, while I'm writing this program out, for your entertainment, let me show you. This is a video that I downloaded by a YouTuber named Mystic, and it's a teardown and like a refurbishing of a fat PlayStation 3, and I totally love this video, and it goes great with some music. Yeah, check this out. Okay.
something spooky I do for him. I'm just wondering if there's something.
if I did everything right, and if I didn't misspell anything, um, and if I copied everything down uh, exactly the way it's supposed to be, then these source code files should build with no problem. Let's give it a shot. Okay, there's our two source code files. I'm going to build the SPU program first. I'm going to use my SPU toolchain. That's it right there. See all those SPU programs? That's all part of my SPU toolchain. And there's my PPU toolchain. That's the one that we're going to use to build the PPU program, basically. So let's run SPU GCC. See if that builds. Very good. No errors. Now, I'm gonna run another program called PPU Embed SPU. And what this is gonna do is it's going to create an object file that we can embed into our PPU code. So they'll basically be it'll be we're going to store our SPU program inside our PPU program. And to do that, I run PPU embed SPU. SPU basic. Okay, that ran without any errors. So now I should have a SPU basic.o, like an object file. Yep, there it is. Okay. Now, this SPU basic program that you see here, this executable file, I can actually run that from the command line right here, and we can watch it do what it's gonna do. Okay, I can do it like this. So that's what our output is going to look like. Hello, my thread ID is blah blah blah. Normally you don't run SPU programs from the command line. As a matter of fact, normally you can't run SPU programs from the command line. They are supposed to be, they're supposed to be loaded onto the SPU cores by your PPU program. But the reason that I can run SPU programs from the command line on my system is, let me show you. Here's my system services that I've got running on my system right now. There's one up here, right here, called ELF SPE2. This is a service. It's like a daemon that I have always running. See, it's on, and run levels 3, 4, and 5. And what that daemon does is it allows you to run your SPU programs from the command line, which comes in really handy for like debugging, purposes and testing and stuff like that. But strictly speaking, that's an improper way to run your SPU programs. Your SPU programs are supposed to be coordinated and executed, by your main PPU program. So that's how we're gonna do it. So, all right, I've got my SPU basic object file ready to go. Now I'm gonna compile the longer program, the PPU program, and we'll find out if I made any mistakes in writing it out. So fingers crossed, hopefully it compiles. The source code file, and that's the SPU program that we're going to embed inside the PPU program. And we're going to make sure to link it with libspe2. That's what that last command does. All right, let's see if this compiles. Okay. Let's find out what I did wrong. Forgot to put an H right there. Let's try that again. Oh, look at that, it worked. Okay, that was my only the only flaw in my code was I forgot to put the H at the end of the header file. Alrighty, let's run our PPU program, our Hello World Cell Broadband Engine program for the PlayStation 3, and see if it does what it's supposed to do. And there it is. As you can see, we ran the PPU basic program, and the PPU basic program loaded our SPU program, the one that says hello, my thread is the thread number, and it loaded it onto a SPU and it executed. Okay, well, now you know how to write a Hello World example program for the PlayStation 3 and the Cell Broadband Engine. So, yeah, hopefully you can appreciate now a little bit more regarding the complexity of the PlayStation 3 and the Cell CPU. If you've ever seen a Hello World program like that runs on a normal CPU, like a x86, it's obviously way more simple than this what I've written out here. Yeah, this is all loading contexts and creating contexts and destroying contexts and checking every step of the way, whether the functions were successful or whether they failed. Wow, perfect timing. We made it just to the end of this Mystic video. Okay. That's nice. Well, alrighty. I guess that's it for this video. I hope you learned something, and if you haven't subscribed yet, then maybe you might want to think about doing that. And yeah, as I learn, as I keep working my way through my my textbook, my PS3 Cell CPU textbook, and I learn more about how to program for the PS3 and the Cell chip. I will make more videos to bring that information to all you nice people. All right. Thank you for watching my video. Have a good day.